Good morning, everyone. Myself, A. Durga Bhavani, working as assistant professor in Marri Reddy Institute of Technology and Management. So today we are going to discuss about a lexical analyzer. So yesterday we have discussed about how the parsing technique and how the tokens are stored in lexical analyzer, as well as how the parsing is going to be done by using a syntax analyzer. The same expression. So we are going to start with the next stage, that is nothing but a functions as well as role of lexical analyzer. So first of all, what is the importance of lexical analyzer we have studied in previous slides or previous class. So the main importance is to convert the given sentence into subparts, that is nothing but a tokens. So that is the first phase of a lexical analyzer. Then after converting those given sentence into tokens, the tokens are stored in a symbol table. So here, so how the data is going to be accessed from a symbol table. So here you can see how that process is going to be happen. So first here you are going to store all the data, that is nothing but a source programming. Then from the source programming we are going to analyze what are the tokens present in that particular source program. So then after analyzing tokens, based on those tokens the parsing is going to be done. So if the parsing is going to be identified any kind of a semantic error, and those are moved to a error handling function. So in this way the processing of lexical analyzing is going to be done. So here next topic is nothing but a input buffering. So what is the purpose of input buffering? So when the data, the lexical analyzer is accessing each and every token. So in order to access each and every token from a symbol table, it uses some kind of memory allocation. So or nothing but a input memory allocations. Those are generally treated as the input buffering. So that means those are stored in that particular table. So how the each and every data is going to be accessed from that. So that can be analyzed by using a input buffering technique. So here each and every token, in that particular token each and every single letter is accessed by using a input buffering technique. So in a given list of a statement, it is stored in some storage allocation, memory allocation. So whatever the instruction is given by a source file, so that entire instruction is stored in this stack allocation or a blocks. So here each and every individual letter, individual character is stored in some block. So here BP is nothing but a beginner pointer, begin pointer, or it is also called as a lex begin pointer, and FP is nothing but a forward pointer or look ahead pointer. So here at the starting stage of buffering, the BP as well as FP both are in the initial stage of this memory allocation. So the main importance of BP is it will initialize, it will tell the block from where the instruction is going to be started, and FP is nothing but a forward pointer. It will tell about the next keyword, next word, or next letter, or next character, so we in which place. So it keeps on moving from one place to another place, that is nothing but one block to another block. So here always this FP is independent and BP is dependent. So this forward pointer is dependent on a BP is dependent on a forward pointer. So here what happens means, in a given set of instructions, suppose let me consider the given instruction is this one, whatever we previously discussed. This is a given instruction. So this is stored in an input buffer. How it is stored means, suppose see this, each and every letter is going to be stored int, and here space. So again MAIN. So again the space, the left parenthesis, right parenthesis. In this way the blocks are occupied by a given identifiers. Okay, so here BP pointer will initialize from here, as well as FP pointer initialize from here. Then afterwards So BP stays at a current pointer and FP will move on it will move from one block to another block. So here what happens means, so FP will start initializing and checking for a next block. So whether it is having a empty space or it is having any kind of a variable or identifier like that, it is going to be identified. So first at the stage, so first FP will store I, next it will move to a N, and then it will move to a T. And here you can see is that the space is occupied in a block. So that means now FP will stop moving forward and it will check, it will give the confirmation to a BP that here it is a space. So that means the block is ended till here. So this is checked whether it is belongs to a keyword or whether it belongs to a variable or it will belongs to some kind of a numeral or any kind of a operator like that. It is going to be checked and analyzed. Then after analyzing, this particular things is stored in a like symbol table, whatever it is going to be identified. Either it is a keyword means it is stored in a keyword, either it is stored represented as identifier means it will be stored as a identifier. So in that way it is going to be occupy each and every instruction. So that is nothing but a forward pointer as well as backward pointer. Next, if suppose the size of given instructions are very large, we cannot tell that always we contain a 10 to 8 to 10 lines of instruction. If we contain more number of instructions, the memory is more, then that particular thing is going to be divided as a two types. That is nothing but the schemes are nothing but one buffer scheme as well as a two buffer scheme. By using this, you can divide the given space into given instructions into multiple blocks. So one buffer is nothing but whatever we have written. So here no space is going to be occupied. So here in one buffer scheme, it will analyze the space as well as it will analyze about each and every instruction. So here you can see the problem, if the very long, then it crosses the boundary buffer. To scan the rest of Lexim, the buffer has to be reshuffled. So here what happens means, so already the buffer size is fixed, like it is having some 20 GB or 20 MB like that, then it is fixed. So there you cannot insert, if the instruction size or if the file size is more, you cannot add remaining tokens into that particular buffer. So to analyze or to manage that space, we are going for a two buffer scheme. So here what happens, the buffer is divided into, the input buffer is divided into two parts, two equal subparts. So based on that instruction, then when you can tell that buffer block is completed or the instruction block is completed means at the end point of instruction EOF is not added. So that is nothing but an end of a file. So for that you can identify, or we can identify the block is ended like that. So these are the methods of input buffering types. So next thing is a specification of tokens. So already we have discussed what is a token. Then there are different kinds of specifications. So how you are specifying the token, this is the token, that is nothing but it contains strings, it contains language, and it contains a regular expression. For example, so string is nothing but it is a group of characters. So here, as we are discussing about a machine understandable language, here we are treating about a finite sequence of symbols from the alphabet. So that is nothing but 0, 1. So here we are checking as a multiple combinational pairs. So here summation is going to be represented as a overall set or overall combinations of a string. Suppose 0, 1. Now if suppose summation of 1 is nothing but, so here it is a 1 combinational pair. Summation of 2 means, so here you are going to take as a 2 combinations like 0, 1 as well as 0, 0 and 1, 1 and 1, 0 as well as 0, 1 combinational pairs. Because I have said that summation of 2. If I am telling summation of 3 is nothing but, here it is a 3 combinational pairs. So Here I am going to include 0. So summation of 2 is nothing but summation of 0 union summation of 1. So summation of 3 is nothing but a summation of 0 union summation of 1 union summation of 2. So like this. So in order to define, if suppose it is containing summation of n numbers, so it is going to be represented as a star symbol. So here it is nothing but a summation of 0, a union summation of 1, summation of 2, like this, keep on showing summation of n. So till here all the combinational pairs are going to be stored. Here in this string is going to be identified. In language what happens means it is a set of strings over some alphabet. So here not only using the combinational pairs, it also contains a empty set also going to be included. That is nothing but it is going to be reflected as a epsilon. So these are the two combinations. So here the regular expression is nothing but whatever the uses some mathematical symbols which are described, like that is nothing but a equal to b plus c. So this is a regular expression. So it provides a convenient and useful notation for representing a token. So here we can by using a regular expression we can easily identify the tokens rather than a given statement of a instruction, bulk of instructions. So how this can be denoted? So this can be denoted by using a epsilon symbol. So these contain three specifications. So first one is a union operation, concatenate operation, as well as clean closure operations. So just now we have discussed, so the union operation as well as concatenate operation as well as a clean closure operation. Okay, so in this way we can perform we can analyze about a regular expression. So what are the combinational pairs here? So here you can see, so a plus b star means, so here you can write a multiple subsequential patterns. So what is non-regular sets? So here we have these are regular sets. So whatever we contain, regular expression contains regular combinations. So what is non-regular sets or non-regular combinations refers to a regular expression called, the language can be defined by using a regular expression, normal expression. Some language cannot be explained by any regular expression. So how we can identify? So some expressions are we cannot write normally. So we should write some different kinds of like dow, like x, like this. So these are not normal expressions. These are not regular expressions, and in this we are not able to identify tokens easily. So at that point, in order to identify, we go with a context-free grammar. So these are the more specifications. So how you can analyze by using a tokens. So first one is a string phase, a language phase, as well as a regular expression stages. And our next topic is a lexical, how we are designing a lexical analyzer or lexical generator. So if we go through this structure, you can identify. So first of all, here it is containing a lex file. So in a previous classes, we are talking about a source file. The source file is nothing but always whatever the programming language we are going to write. So it is going to compile and it will generate a one executable file. So while compiling, it will generate a binary coded file, that is nothing but an object file or a binary file. So here, while analyzing about a lexical analyzer phase, by using a lexical generator tool, we are going to generate a lex.yy.c file. So which we are treating as a one kind of a binary file in a normal programming language. So here all it contains all the lexemes whatever present in that particular source file. So that is analyzed by using the lexical compiler, and that analysis of tokens are analyzed by using a C compiler, and output file is going to be generated, and that output file contains a whatever it is related from a source program, and it contains a stream of a token. So what is the result it will contain? Next, so this is a structure of a lex. So in order to write a lex program, first declaration. So how you are declaring means, the initial stage of declaration, the lex program always start with a modular division as well as a open parenthesis and modular division as well as a closed parenthesis. So the initialization of a Lex program starts with this in this form. So here we will write what kind of statements you are going to declare, and in the rule section, that means if you have any kind of methods or functions related to the source program, that is going to be write in a rule section. So here this percentage by percentage as well as percentage by percentage or modular division, so these operations are going to be used. First declaration of statements we are going to write in this, and here we are going to write the function as well as a method or some kind of a functionality should be done by using those source program. And here you are going to write what is the methods and what are the variables you have used in this particular Lex program. And next we are going to discuss about a Lex analyzer. So here how this Lex analyzer using transition diagram. So first of all, in order to access data from symbol table to lexical tool or lexical analyzer, and how data is accessing from lexical analyzer to a symbol table. So first time by using a source code, the lexical analyzer will access all the tokens, and those tokens are stored here. Now in order to identify, in order to perform a compilation process, the symbol table should provide a data to lexical analyzer phase. So that means transaction has to be done from one place to a other place. That is nothing but it. Now this symbol table will contain all the variables what the source file containing. Okay, so now these variables has to be accessed by using a lexical analyzer. So for that purpose we are using a transition diagram. So what is the purpose of transition diagram? So it will tell the symbol table or a lexical analyzer will identify. The lexical and uses transition diagram to keep track of information or about the characters that are identified as a forward pointer scan the input. So here what happens, which variable has to be moved to a block where the forward pointer has to stop, where the forward pointer should identify, where the forward pointer is identified. This is a space, this is a variable, this is a identifier, this is a keyword, this is a operation, this is operator, this is a like numerical value. So where it is going to be identified, how it is identified, that is analyzed, and that is going to be represented as a states. Okay, so it contains the position in the transition diagram are drawn as a circle. Okay, so when the instruction is initializing, the instruction is starting, that starting stage till the end stage of that instruction are represented by transition diagram. So those are represented as circle. So here initial state of state is represented as a single circle, and final state is represented as a double circle. Okay, so that means here you can tell that this is the initial state and this is a final state. Okay, so here what happens, and in order to communicate or in order to make a connection between initial state to a final state, we are using a arrow key which we are calling at the edge. And here which is accepting all the inputs, that is nothing but a accepting state. So here if I'm drawing like this, so this is also accepting the inputs, so this is also treated as a final state. Okay, so not final state, this is also treated as a accepting state. Always the accepting state is represented as a two circles. That is nothing but it is having multiple data inputs. Suppose, just let us glance over the structure here. If I am writing A, B, so that is nothing but I wanted to make a communication between A and B. I wanted to store the data as A and B. Okay, I want to represent. So what I will do, so 0, that is nothing but writing. So A is transferring. And what is the leftover letter? B, B has to be transferred. So B. So this is a final state. Okay, so in this way we are going to identify. So A as well as B. Suppose if I am having A as well as B. So now how I will represent 0 state? A is moving. Again one more A has to be moved. Again B letter has to be moved. So this is a final state. So this means, so at the letter 3, at the very number 3, so we are having a as well as B. If I am having A star as well as AB, so now what I will do, same process. So here the self loop is going to be represented. Okay, after n for second variable I am going to write as a star. So whenever star is represented, it is represented as a self loop. That is nothing but the data is going to be transferred from A to A. So already A and here A, so data will, asterisk will be presented here. So this is the initial state, this is accepting state, this is a edge transition, and here input retraction. That is nothing but a iterative statement or iterative transactions are present. So those are represented by A star. And next, how it is going to be work. So already we have discussed from start state to 0. Always the state is a 0, that is a start state. If the first character is a letter, it moves to one state. Okay, so always if you wanted to print something, we will write written 1. If you want to print nothing, we will write as written 0. That is going to be identified being by using a 0 as well as 1. If a state 1 is accepting the states were identified, it says state 1 is long as the digit or long letter or a digit. Next, two characters are encountered means more than one character it is encountered means we will going to represent as a star retraction. Okay, so like A star. So like again next state 2 is a dead state, like 0, 1 as well as 2. Okay, so 0 as well as 1 is going to be accepted. This is going to call as a dead state or a end state. Thank you.